All right, guys. So the volume may be a little bit louder. I only realized just a moment ago that my NVIDIA audio recording volume was set to like 43% for some weird reason. I don't know why it's always doing that. It's always like automatically changing my volume for me without me doing anything. Anyway, it's not important. So the volume's set to 100% now. So let's go ahead and get started. In this video, I'm going to be covering the skeletal mesh, basically things that are important for you to know about the skeletal mesh. The main thing to start off with is bone hierarchy. So you'll see that this IK foot root, if you follow this line from this arrow, it goes into this arrow, which has a line going to these bones. And then you'll see it's a tree hierarchy. So these bones are children of this bone, which are a child of this bone. That means that if I move the root bone, all the other bones that are children of it automatically come with it. And if I move this bone, those IK bones come with it because it's a child of it. Now, if you look, I have this set to local space coordinates right here. That means it's showing the local coordinate of the bone that I have selected. So you'll notice that the orientation of this is different if you look at the arrows. So the red is X, the Y is green, and the Z is blue. So Z is up in the scene, but X is up for this bone. If we select this other one, X is down for this bone, and Y is facing back this way instead of forward in this direction. And that's probably not even, I doubt that's actually aligned to the world Y. So if we come over here into this camera option here, we can go to top, and you'll see that it's at a slight angle from the true Y of the scene. So I'll get into spaces later, but it's important for you to know that the scene space right here is basically equivalent to component space. It's good to think of it in terms of that because this root will be what's connected to the component, and this root can be rotated differently than the component space. So a component, these are components. So you have a mesh component right here, and it's assigned a skeletal mesh component. So although in the viewport, I can't rotate the root relative to this component, I can from the animation blueprint, or from animation for that matter. The coordinates that you see right here are relative to this component. That's this component's orientation within or opposed to the capsule. So this one has a negative 90-degree rotation, which means it's facing forward along the X direction. Let me see. It's, yeah, facing forward along the X. That's because normally with character movement, the character movement component expects this X to be the forward direction. But when we're working with meshes and static meshes, we normally have the Y direction, the forward direction. And that's just a kind of difference in convention between things. So if you look at this scene right here, the forward direction is Y. How do I know that? That's because whenever you have it facing forward in the scene, he'll look like this. He'll be facing forward in the icon. So people just, they treat Y as the forward direction for this scene, for characters that they bring in static meshes. So With that said, we've covered the bone hierarchy. Another thing is bone naming convention. So different there's different naming conventions for different types of skeletons, but in Unreal Engine, they have pelvis. The pelvis is called pelvis. Some characters you might see, they call it hip or something like that. And then you have your spine bones. You have your clavicle. Some characters will call it shoulder. You have your upper arm and your lower arm. And then you have your hand. I've seen some characters where they call this the forearm instead of the upper arm. So if you're going to bring in another character, just having the same like bone structure as this isn't enough. They also need to be named the same because if the bones have different names, then Unreal Engine is going to assume that it needs to add those other bones, even if it's called pelvis and the one you're bringing in is called hip, but they're both under the root. Unreal Engine will have to add hip, a hip right here, and then whatever bones is under that hip. That's assuming that you're bringing it in onto this skeletal asset. Another thing to note is that when you're sharing skeletons, it's not enough to have the same naming convention and the same bone hierarchy. Another thing that's very important is also the bone roll. So the bone roll is its local orientation to its parent, basically. Whereas like with the pelvis, you'll see that it's pointing forward in the Y direction. So if you bring in a character and it has the same naming convention and bone hierarchy as this one, but let's say that its pelvis's bones Y-axis is pointing in the opposite direction, or it's pointing to the character's right, which is left in this from this perspective, then when we roll the character like this in the animation around the Y-axis, on the other character, it'll rotate it like this instead, because it's not going to know that you think it should be rotating this way. All it knows is that it's rotating along the Y. So if the other character's Y is this way, then that's the direction it's going to rotate it. It's important for you to know that. So bone roll is very important, because I've seen characters get brought in and the lower arm bone, its Y direction is pointed in the opposite direction. And so, or it's actually, I should say their Z is pointed like down or something. So whenever this character's arm gets rotated forward in the animation, their character's arm is going to be rotated back. So make sure that you check your bone naming convention, your bone hierarchy. Avoid bringing in characters with bones that don't exist on the other one, because it'll get added to the skeletal asset and those get evaluated. You'll end up with this huge skeletal asset with hundreds of bones, and performance will be very bad, because bone evaluation, the number of bones it has to evaluate, it has a performance cost. It has to go through each one of those bones every time that a node on the animation graph is called and perform an operation on those. So the more bones you have, the more laggy or the less performant it's going to be, basically. Which is why the cinematic version of the metahumans, they have a crap ton of bones, But if you look at the game ready versions, they have they have very much reduced the number of bones on those characters. I do believe. I remember looking at it and noting that. So that's not even enough, though. Another thing you need to understand is this pose that the character is currently in. Now, a lot of times people will put their character in an A pose like this, and they'll think, okay, it looks the same, therefore it must be the same, right? Wrong. So just because a character looks, let me see if I can find, okay, that's the rigs, okay. Just because a character's base pose looks the same doesn't mean that it actually is the same. And let me see, I haven't looked at this one. This one might be different, but you'll see that we have, under the details, we have the bone name, and then we have 3 categories. We have bone, reference, and mesh relative. I don't think mesh relative works currently. I believe that's supposed to be the mesh space or the scene space location of the bone, the location and rotation of the bone in scene space. The reference pose is its parent bone's rotation when they're in their base pose. And the bone transform is its current rotation. So if I rotate that, you'll see that this changed, but this did not change. This is still 17. This is negative 62 now. So you'll see this is 17.246. Let's see what it is on this one. 14.457, okay? So that proves my point. So a lot of people assume that just because this pose looks the same, it looks like they're posed the same, that does not mean that it actually is the same. So a reference pose, if the angle is different right here, that will have a chain like domino effect that ripples through the entire body all the way down to their hands. Why is this important? Whenever your character is in a precise position, let's say they're holding a rifle, their left hand needs to be on the barrel of the rifle. So let's say that I made an animation where the Manny Simple is holding the rifle completely perfectly. His fingers and hands are on the barrel of the rifle exactly where I want it. Now I play that same animation on this one, and suddenly it's not where I put it. That's your chain reaction. So whenever the base pose is different, or the anatomy, what is the anatomy? How long is this bone? So let's see, if I go over to the thigh, you'll see the length of this bone right here. The length of this bone is going to be different on this character than what it is on this one. These characters are not the same height. This one has broader shoulders than this one. Now, why would broader shoulders make a difference in hand placement? Well, it's because when you play an animation on a character, you're just rotating their bones. So if I rotate the arm, if I rotate all these bones the same way I rotated all these bones, the end of the chain is going to end up, both of these hands are going to end up in 2 totally different locations in this scene. And that's because when I rotate the spine 1 bone, the entire body rotates with it. When I rotate spine 2 bone, the entire body rotates with it. If I reset spine bone 1, you'll see it did not affect the rotation of spine bone 2. Spine bone 2 is still rotated. You see? So it's a chain reaction. Whenever you're propagating rotations along a chain, you end up in two totally different locations depending on the length of the bone and the pose with, or the angle with which it's being rotated. So I'll cover ways to fix that later, okay? I just want to make sure that you understand why we have these problems. You need to understand how this stuff works. If you don't understand these things, you're going to fall into the same traps as everybody else. Everybody thinks you can retarget an animation from one character to another and you do not have to do any extra work. It automatically places everything where it's supposed to be. I've had somebody argue with me over this. I've actually quit a job that I was working on with somebody because they just would not listen to me. If you listen to this logic, you will understand why certain things happen. All you have to do is just understand it. And this is the part that nobody talks about, which is why I created this channel in the first place, because I want people to understand this. When you understand this, you'll be ahead of everybody else. Reference pose, base pose, whatever you want to call it, anatomy, all of that stuff, it has an effect on how animations play between characters. Like I said before, if you have a rat hold a tank, is he going to be able to have one arm on the back of the tank and the other arm on the front of the tank? No. But if you get a giant and you have a giant do it, then yeah, he's going to be able to hold both ends of the tank. The point is that the size of the character has a major impact on how they handle things. If you have a child holding a rifle, a sniper rifle, is he going to be able to hold it in the same manner that a grown adult will? No, he will not. If you go look at references and videos, you'll notice something, and that's that whenever children hold guns, they have to basically stand sideways because their arms aren't long enough to hold the barrel of the weapon while aiming it. They can't hold it in the same way as an adult where it's on their shoulder and they're aiming forward. That's something that a lot of people, whenever they approach this, they don't think about. And it's very important for you to understand this, because if you don't understand this, you're never going to be able to build an actual animation system. So the reference pose, what's affected by this? Additives, deformation, retargeting, animation bone orientation, and socket orientation. So if you share a skeletal asset between two different characters and their bone orientation is different, and you added the socket to be right above the thumb on one, but the bone is rolled in the opposite direction on the other one. I haven't tested this, but I'm just assuming that if that were the case, then the socket location on the other one would be in the opposite direction. It'd be over here because it has a local space orientation that's relative to the roll of that bone. So animation bone orientation, I've already went over that. If we're rotating in this direction on this one, but the other one has the opposite rotation, then it'll rotate this way instead. Deformation. The reason why a lot of people use the A pose is because it's kind of a middle ground between over here and down here. And the thing is, a lot of people used to use the T pose, and the T pose is good if you're going to be raising your hand, if your character is going to be raising its hands a lot. I'm going to have to explain to you how weights work for you to properly understand that. I'm going to do that in the next video. So I'll cover that part in the next video because, like I said, I want to keep these videos short. And I think I've already been talking for quite a bit in this video. But basically, the reference pose in regards to deformation, it has a major impact on deformation. So if you chose a pose like this, you'll see that if I bring it up just above shoulder level, the arm, you'll see it loses volume right here. Now, had you weighted this in a T pose, you wouldn't be losing volume right here. And that's because of how weights are handled. So I'll get into that in the next video, just kind of like briefly going over that part of it. Additives. So additives are added to the current pose. In some situations, additives might be based on the reference pose. So in that situation, if you have an additive applied to another character with a different base pose, but it's the same additive, let's say for whatever reason you're sharing the skeleton, but both skeletal mesh assets have different actual base poses, it's going to treat the other one as though it has the same base pose. And when it calculates the additive, it's going to apply it just like it would on the character it was made for, but your character has a different base pose. So the angle 40 on your character might put it up here, depending on the base pose orientation of that bone. Okay. Let's see. Okay, I think that basically covers it for this video. So in the next video, we'll go over weights and a little bit about deformation and weights, just to cover that a little bit more thoroughly, and I'll see you in the next video.